Have you ever just stopped and wondered about the absolute magic that's happening inside the phone you're holding right now? I mean, how does it manage your entire life, all your photos, your music, your conversations? Well, it all boils down to a surprisingly simple idea. We're going to peel back the layers on this and show you the fundamental secret that powers everything from your smartphone to, well, the entire internet.
So here's our game plan. First, we're going to crack the computer's secret language. Then, we'll hop in a time machine and witness the birth of the first computing giants. After that, we'll zoom forward to the digital tools we can't live without, take a peek under the hood at the software that makes them tick, and finally, see how this whole incredible story is changing the future of learning itself.
All right, let's dive right in and unlock the code. You might be shocked to find out that every single complex digital device is built on one incredibly simple idea. This right here? This is the secret that powers our entire connected world. So, let's start with a big question. Just think about it for a second. A movie is all flowing colors and sound. A document is just text. Music is this complex wave of audio. So how on earth can one single machine understand and process all of these wildly different things? Well, the answer is surprisingly elegant.
And here it is, binary. That's the secret. Deep down, at its core, every computer speaks a language that has only two words, 0 and 1. That's it. These digits represent the off and on states of billions of microscopic little switches called transistors. So get this, every photo you take, every song you stream, it's ultimately just a massive, coordinated symphony of tiny switches flipping on and off at unbelievable speeds.
This image just perfectly lays out the key difference between digital and what came before it, analog. A digital signal is like your basic light switch. It's either all the way on or it's all the way off. There's no middle ground. An analog signal, on the other hand, is like a dimmer switch. It gives you that smooth, continuous flow of possibilities.
Here's another way to picture it. Digital information is kind of like climbing a set of stairs. Each step is a distinct, separate value. Analog is more like walking up a smooth ramp, a continuous, unbroken line. It's that precise, step-like nature of digital that lets computers make perfect copies and run flawless calculations every single time.
Okay, so we've got this incredibly powerful concept of binary, but how did we get from a simple on-off switch idea to actual working computers? Well, that takes us to our next chapter, the dawn of the computing giants.
You know, the 1940s and 50s were really the heroic age of computing. In 1943, you had the Harvard Mark I calculating tables for the U.S. Navy. Soon after that, the legendary ENIAC came online in '45. And then by 1951, the UNIVAC I made history as the very first computer you could actually go out and buy. These were the pioneers that kicked the whole thing off.
But let's be crystal clear. These were not machines you could just pop in your backpack. They were absolute behemoths. These first-generation computers took up entire rooms, they were outrageously expensive, and they guzzled electricity. And why? Because instead of tiny transistors, they were running on thousands of big, hot, and pretty unreliable vacuum tubes for their switches.
Okay, let's hit the fast-forward button. We're jumping from those room-sized giants all the way to the technology that literally fits in the palm of your hand. This is the incredible toolkit that has evolved from those early clunky days.
The legacy of those early machines is all the tech we now completely take for granted. I mean, think about it. Your smartphone is millions of times more powerful than the ENIAC was. With a search engine, you have more information at your fingertips than was in entire libraries just a generation ago. Every document you write, every photo you snap, it's all standing on the shoulders of those room-sized giants.
And the evolution is just speeding up. We're now turning digital information back into physical objects with 3D printing. We're literally weaving technology into our bodies with wearables and into our homes with the Internet of Things. We're even creating entirely new kinds of digital money, like Bitcoin. The digital toolkit isn't just growing, it's actively reshaping our reality.
So we've talked about the hardware, right? The physical machines. But what's the thing that actually tells them what to do? That's where software comes in. And there's a really important difference between the two types of ghosts in the machine that make it all work.
To put it simply, software is just the collection of instructions that directs all the computer's hardware. It's the brain telling the body how to move. I mean, without software, even the world's most powerful computer is really just an expensive paperweight.
Here's the key distinction, and it's a great way to think about it. System software is like the manager. It works totally in the background, making sure all the computer's basic functions run smoothly and that all the physical parts are talking to each other correctly. Application software, on the other hand, well, those are the specific tools you choose to use. Your word processor, your web browser, your photo editor, to get a particular job done.
So here are some examples of that manager software. The big one, of course, is your operating system: Windows, iOS, Android. Then you've got things called device drivers, which are these little bits of software that let your computer talk to your printer or your speakers. And then there's firmware, like the BIOS, which is the very first thing that wakes up your computer when you hit the power button.
And these are the tools you're probably way more familiar with. You know, word processors for writing, web browsers for getting online, and multimedia software for all your creative work. These are the applications that sit right on top of the system software and let you actually do stuff.
All right, so we've gone from binary to giant computers to the software that lives in your pocket. Now let's pull it all together and look at the incredible impact all of this technology is having in one of the most important places there is: education.
I mean, the impact of bringing this tech into the classroom is just profound. We're seeing it boost student motivation and confidence like crazy. It's completely knocking down geographical walls, connecting students with kids all over the world. It's unlocking brand new ways to teach through games and virtual labs, and it's giving students hands-on experiences that used to be impossible or way too expensive or even dangerous.
This quote just nails it, really. It's not about just swapping out textbooks for tablets. It's about fundamentally expanding what's even possible in a classroom through way better collaboration, deeper interaction, and much more effective communication.
And all of that leaves us with one final, really fascinating question to think about. We've traced this incredible path from a simple on-off switch all the way to today's powerful learning tools. So as this technology keeps getting smarter and more woven into our lives, what does the classroom of the future actually look like? It's pretty exciting to think about.